Toxicity assessment and dose response relationship and exposure assessment is the main three steps of this assessment. Especially environmental engineers are very good at exposure assessment. So, and also engineers are good at the modeling. They are good at the computer simulations. So not only the assessment or not only the simulation of pollutants in environment, but also movement of the pollutants in your body, in human body. So those are also the role of the engineers or environmental engineers. So I explained the exposure paths and the target chemicals exposure paths. And this afternoon, I will begin with the explanations on toxicity or toxicology. Also, the basic knowledge of toxicology is also important for environmental engineers for risk evaluations. Not so special, just like the medical doctor, but also at least the basic knowledge of toxicity is essential, also essential for the engineers. Okay, now the toxicity to be considered. These are the just terms and principles in the toxicological studies. The most important word is sentence is whether it is natural or synthetic. Every chemical substance has a toxicity. So every chemical can be toxic. Even sugar or salt. If you eat salt, or for example, 1 kilogram of salt at one moment, maybe you will be dying. So even salt is very, of course, it is essential for the human health, but too much is toxic. So the important thing is dose. Every chemical can be toxic. The dose is important. So even salt and sugar, if you take too much, it can be toxic chemicals. So those are the very basic principles of the toxicology. Sorry. So some people think just artificial chemical is toxic and natural chemical is safe, but it's completely wrong. So those are very important. For another word is those makes poison. Those makes poison is also very famous word. Those are basic principles of the toxicology. Okay, and there are some words, basic words in toxicology. Acute exposures. Acute action by one contact or one intake. And the chronic exposures, almost intake for the life. So in case of human beings, it depends what about 70 years or something. But in another animals, it is just 2 years. Anyway, so chronic exposure is almost immediate for the life, all of them. Some chronic exposure, the repeated exposure in some period of lifetime. Usually, in case of human beings, it is about several years to 10 years. Also, it depends on time. Annoying mammals, just like mouse or rat, and the chronic exposure is daily feeding for 2 years. This is chronic exposure because the average lifetime length is about 2 years. And subchronic exposure is daily feeding for 90 days. This is the subchronic exposure for the mouse or rat. Also, target part of the toxicity. Chemical substances are classified by the target organ or the system that the toxicity of the substance develops. These are the examples such as hepatotoxin and neurotoxin and skin poison and so on. And most chemical substances extend over the neural targets. And the target organ varies according to the exposure condition, and even if the target organ is the same, the poisonous action can be different. These are also important knowledge you need to consider. So even uh, if even in some standard is based on the toxicity in some organs, so but the same chemical can make the another toxicity to the another organ. In special case, you also need to consider those another effect. Okay, this is just a basic knowledge, basic word to understand the toxicity. So first one, the acute toxicity. Rank of the strength of the acute toxicities. So botulinum is just natural chemical substances, and the toxicity that is strong for nervous systems. And a few mixture of the bacteria is further, and it is further by an ounce intake of 0.00001 million per kilogram body weight. So if you take just 0.00001 million per kilogram body weight at once, maybe it can be the test of it can be test. So it's so toxic. It is natural, but it's so toxic. And also sugar, another example. By the rat experiment, they were died by the dosage of 20,000 million per kilogram body weight. So just 20 grams per kilogram body weight. It means around 1,350. So over 1 kilogram. If you take sugar, just sugar over 1 kilogram at the same time, so it can be tasty. So further dose is different between botulinum and sugar for 10 million times. So even in case of botulinum, so just 0.001 million per kilogram weight makes less. And in case of sugar, it's about the 1,000 grams. So chemical substances are ranked according to the vital dose in the single applications. So this is the toxicity ranking. The practically non-toxic, slightly toxic, moderately toxic, very toxic, very toxic, and super toxic. And this is the lethal dose. Maybe there's no probable lethal oral dose for humans. Or I should say maybe this is lethal dose 50. About 50% of the people die at the level of these doses. So in case of the practically non-toxic, even if you take it's a milligram, so 15 gram per kilogram body weight, if you take, you can take about 15 gram per kilogram body weight without test, so you can say it is practically non-toxic. So about the ranking of the coding gas, and in case of super toxic, even less than 5 milligrams per kilogram body weight dose makes test. So depending on the lethal dose levels, so we can make a ranking of the toxicity of chemicals. For average adult, so this dose is about 1.1 kilogram for one adult. Sorry, I got this number from the textbook in USA, so the code to find it or something. But in kilograms, so this dose is about just 1 kilogram or just 7 drops. Just 7 drops makes this. If 7 drops makes this, you can say it's a super toxic. These are the acute toxicity. So even if you are not die, even if you take almost these doses, but if you are not die, maybe you will recover. You will recover. sorry. And typical chemicals about the misunderstanding of the toxicity is the dioxin. So in Japan, we go to the dioxin panic. We call it the dioxin panic because almost all newspapers or TVs are very complain about the concentration of dioxin in the medium or environment, soils or vegetables or water or something. And they bound to use the initiation plant, for example. And yeah, anyway, so many people are very afraid of dioxin about 10 years ago. It was almost the panic in Japan. But we say dioxin is very, very toxic or even super toxic. But it depends on the result of this experiment. So in the further dose of 2378 tetrachlorodoxin paradoxin for female new pig, it's just like a mouse, or a small mouse or rat. And it was 0.0006 million per kilogram body weight. So it's almost the same as the protein and so super toxic. And the dioxin can be also spread all over the environment. So many people are very afraid of it. But further dose of the hamster is approximately 5 times more of this value. The hamster and this new pig is almost the same. It's almost the same kind of the mouse or rat. But the further dose is so different. But but problem is we are not sure about human beings. How much is the further dose for human beings? So we are not sure. So to make the standard of the concentration of dioxins, we need to use these values, not these values, because of the conservative policy or the safety policies. Because we are not sure about the effect to the human beings, yeah, we use these values. So many people are afraid of dioxins, and also some of the mass media makes almost panic because already dioxins spread out to the environment, and even some concentration of dioxin in some human beings are clear. It is observable. So it was also big panic. But now recently we found further dose to human beings about the middle of this value and this value. So not so, it means dioxin is not so toxic, not so super toxic to human beings. From the experience data, some workers are suffered from the dioxin, and some workers are exposed to dioxins, and from the estimated the exposures, but they are still healthy. So from those experience, we now our conclusion is human being is not so weak but not so strong. That's the real situation. So the most of the exposure to such substances occur because of the accident in production and the process of the circulation, but such accident is not rare. So such accident is rare. So we don't have enough data, so we cannot clearly say that is not so big problem. So even now we are using the standard production based on its value. But actually not so we don't need to be afraid of that not so much. Yeah, this is also the example of the Bhopal of India, accident in India. approximately 40 tons of methyl isocyanate was released in the atmosphere, and more than 2,000 or 3,000 people were killed because of these chemicals. So, based on the toxic rank, we should handle them carefully. So, this ranking is very important. So, to know, we should be very, very careful and also careful. So based on this ranking, we should decide how to take care of such chemicals. And if it is not causing the test, so exposure level does not lead to causing test. We cannot also ignore the measures to health expect the test. So from the stimulation for skin and eyes, which is extremely slight and completely reversible to the serious injury of its target part. So the property of adverse effects based by one exposure of a chemical substance changes with its quantity. It is also the characteristics of the acute toxicity. Based on the dose or based on the quantity you take at once. So the property or feature of the effect is different. So this is also the another characteristics. I'm sorry, this is the example of alcohol, and Muslim people don't drink alcohol, but it is very common for Japanese. So even slight amount of alcohol, no harm that we can take. But very small amount of alcohol makes the feature of the getting drunk. That is loss of the cooperation movement or haze of the eyes or low of reaction time or something like that. And if you drink more, so language distinctness and even more conversions and coma and finally test. So depending on the dose or depending on the quantity you take, the feature of the effect changes. That is also characteristic of the acute toxicity. So the poison action of all chemical substances depends on dose response relationship. So you shouldn't say some actual chemical is toxic or non-toxic. Every chemical can be toxic. Every chemical can be non-toxic. It depends on dose response relationship. So be careful. Even some citizens, just normal citizens, uh, don't consider this phenomenon. They want to know this chemical is toxic or not toxic. So you should be careful. And when those increases, the length of the response increases, and target part may change. Just like this. So influence of the exposure path also makes the exposure path makes some influence. The example so far is about oral path. There are also other paths eaten by animal or insect or direct input of venom to blood or volatile chemicals influences respiratory tracts for lung and skin. So also, depending on the exposure path, the effect is different. And the method to understand the toxicities. So three basic methods to define toxicity. Case study, epidemiological study, and animal experiment, or animal test. So case study, this is example. Just a carcinogenesis with arsenic becomes clear by the report from the doctor who observed the reactions on the skin of the patients from a kind of pharmaceutical product, including arsenic, was prescribed. So this is the case studies. Case studies for the human beings. But because it is not the scientific study under controlled conditions, the decision of the causation is difficult when the exposure situation is not clear. Even Minamata disease in Japan, at first, many people or some people say it is not because of mercury. but because of some kind of the local disease or something. So not anyway. So in case of case studies, it is difficult to say clearly the cause of this disease is this chemical or not. And the epidemiological study is much more important for the source of information to know the action of the chemical substance for the human body. Example is the consistent correlation